Welcome back, guys. I trust that you enjoyed your last session. We've got another very important part now of Module 2. So there's 5 parts for Module 2, and you've done now DocuCenter and the fenestration types, norms, and furniture. I trust you enjoyed that part. And what we're going to look at now is part 2.3, which is safety systems. And in South Africa, we believe there's a real opportunity here because there are not many options for glazed fire doors. And there's also potential for security and bullet-resistant doors because these steel building systems give you ready-made systems to allow you to create doors and elements that have been proven and are actually verified or certified to certain resistance classes, which are based on the European norms. The one following that a bit later on will be non-insulated steel building types, but for now, you're going to be looking at safety systems. So trust that you all enjoy it. I'm going to hand you back to Andreas.
You should see the safety systems overview.
Yep, can see it.
Good. So here I will just show you what are the possibilities with steel systems. There are plenty of them, and just as an introduction, you can do more with steel than with any other material. And let's just have a short look at this. First thing is burglar resistance, the so-called RC class. Here, let's say that the goal is to prevent the burglar from entering through the window or through the door by either breaking the glass, but that's taken care of just by the glass of the glass, or by removing the glazing bead, or maybe manipulating the lock, or manipulating the hinges. So these are the elements that we need to protect most of all. All in all, we have, besides the burglar protection systems, we have fire protection systems, bulletproof protection systems. Okay, the emergency exits, panic functions, or panic doors are also considered safety systems. The burglar resistance and the so-called finger protection, or finger protection. Here you protect most of all small fingers, children's fingers from getting squeezed between the moving parts of a door. So for that we have some systems to protect that element, and I will show you now one by one what we can cover. Fire protection. How much do you guys know about fire classes? E, EI, EW?
It was brought up in David's inauguration.
Mm-hmm. Okay, then let's just run quickly through it, and then again you can use this document as a reference to look it up again. We have basically two main fire protection classes here in the world. There is some classes in between, some, let's say, in between classes. The first one is E, which is just a one called the integrity class, or comes actually from French. Étanchéité means room closing, room tightness. This type of fire protection is only supposed to keep the fire and smoke away from the burning part, from the one sector of the building, from the other. This class will not prevent the thermal radiation from passing through the element. So it protects the let's say the protected part of the building only for a short time. After a while, you will have a self-ignition on the other side. The thermal radiation will pass through, and you actually will the flammable elements will ignite after a while.
Yeah.
So here again, I think the film shows it just briefly. It's just meant for these sections of the building where you just evacuate quickly. You see, you run, that's good enough. You will still feel the heat, but it will protect you for the first couple of minutes. The systems that Janssen offers are the facade systems in this class, and here you see the minutes. E30 is 30-minute resistance, 60, 90, 90. Also on the Janssen Economy doors and well, windows to a limited extent, you can also build in this class. And Economy 60 is also suitable for this type of fire protection. What you also see here on this cross section of the profile is that there is no thermal break and no cooling element in the profile. It's basically a pipe. It's a tube. Yeah? So it will transmit the radiation through. It will let it pass through. That's class E. It's the cheapest class, cheapest fire protection class. Yeah, and it's used for these section of the building where you just quickly get out of your, let's say, your department, your compartment, and you're out. That's it. Here again, a close-up. You have no thermal break. It's just like one shell, one tube system. You see the gaskets here. You see the distance tape or the glazing gasket, but that's it. And here the glazing bead that keeps the glass in place. Typical example of an Economy 50 or 60 fire protection element. Then we have the so-called EW class. E is E plus W. I don't know where it comes from, the W, but it means it will also protect the protected segment or section of the building from thermal radiation. It will not protect it totally, it will protect it to a certain extent. And this value is also given by the norm. It is lower than 15 kilowatts per square meter of the element. Yeah, so it will reduce the thermal radiation to some point. It will not eliminate it, it will reduce it. So this is one of these in-between classes. And let's see how they show the use of it. It limits the radiation, but it will not stop it completely. Yeah, so you have a little more time to get out, but in the end, at some point you may get some you know, melting or some effect here on this side. This is the class that we quite seldom use. They're not really, let's say, approved for all the countries, for all the markets. In some they are. So they are like this in-between class. What's more, okay, here the systems. We can do facades in this class, as you see, between 15 and 45 minutes. We can do doors, Economy 50, Economy 60. Here classes between 50 and 45, and I think it goes even further depending on the glass that you use. And here, by the way, look, you see a drop-down ceiling that is installed in the sill section of the door. See it?
Yeah, I see it.
That's it. That's it. Oftentimes used to stop the fire from entering to the other section of the building. Yeah, drop-down ceiling. It's equipped with a rubber sleeve, and it's a perfect closing element. Okay, so this would be the EW class. Let's say the highest class is the EI class. This class will stop fire, smoke, and thermal radiation. The abbreviation comes from, again, étanchéité isolée from French, and it means it's a room closing with the thermal break as well, thermal protection. And these elements are built oftentimes, you know what, can you hear the voiceover?
Not there for a second, no.
No.
Okay, because let me just see if I can activate it. Just a second. This would be important. Okay. All right. So I'll just run the movie, and I hope you can hear it. It's just a description of it.
E-class, yeah, full insulation. These are high-end products that can actually act as a barrier to radiant heat, restricting the heat to less than 1 kilowatt per square meter at 1 meter distance. You can stand near the glass on the non-fire side and not feel the heat.
Okay, so this is, let's say, the the upper class. This is the Mercedes of fire protection. It will protect you totally from the heat radiation as well. And these elements are used in the safety areas, for example, stairways, where people gather. Well, you have to provide a longer time of fire protection. We can build facades in this class. We can build the doors based on Yanisol C4 for 60 or 90 minutes. And on Yanisol 2, I will explain later on the difference between these systems. In the class of IE 30 minutes, sliding door we can also do in EI 30. What is different now in this class, or when you compare it, what makes the difference in the profile? One is the thermal break. As you see, compared to the economy to the E class, the EI class has an insulator, so it features two half shells, two steel half shells. These half shells are connected with an insulator. It's a fiberglass reinforced plastic. It's rolled into the profile and it keeps it together. In addition, you will have two plaster or ceramic inserts on the Yanisol 2 on both sides. And these are the fire protection materials that cool the element and prevent the radiation from passing through the profile. The glass itself on the EI class is a multi-layer glass, and between the glass layers you will have a gel, a cooling gel or liquid that is not visible, but once the fire hits the glass, it starts reacting. It becomes opaque, and the glass actually breaks, and the gel or the liquid evaporates. And this is the cooling action of the element, of the glass. So cooling element, yeah, clear? Makes sense?
Yeah.
Mm-hmm. And now the class, if it's, depending on the resistance, you will have either 5, 10, or even more layers of glass, depending on the class you want to. The higher the class, the thicker the glass, the more layers. Mm-hmm. So you see here, Yanisol 2 is good for the class of 30 minutes, EI. Yanisol C4 is good for classes 60, EI 60, and EI 90, depending on the glass. The difference is just the glass here. What this profile features is, again, a thermal break between the two half shells. And what's different here compared to Yanisol 2, it is fully filled with a ceramic mass. So the cooling function is much greater. It's much more pronounced. This element can resist, or this profile can resist times up to even 2 hours. But we have tested it. We're actually testing it for 2 hours sometimes for project solutions. So this is how we handle fire protection. Okay?
Okay.
All right.
Looks good.
So now we have a movie that shows the...
This 1-hour fire test to US standards compares the product performances of...
Can you hear the voiceover?
Yes.
Okay,
Yes.
excellent. Then let's watch this movie. This will bring it now to the point. It will just summarize everything I told you before, and it is also showing you the effect of the fire on an insulated system versus non-insulated. Let's watch it. It's, I think, 5 minutes, but it's worth it.
This 1-hour fire test to US standards compares the product performances of fire resistance rated intumescent glazing to fire protection rated non-intumescent glazing.
Here you see the stickers slowly coming off the glass. This is the non-insulated. Smoke development. We will have some self-ignition in a moment. On the insulated side, nothing. You see here the opaque color of the glass. The gel has already activated. Now 20 minutes later.
At 20 minutes, the radiant heat transfer through the fire protection rated glass is reaching critical intensity levels, and potentially harmful gases are being generated by objects exposed to the intense radiant heat passing through the glass. A heat flux greater than 15 kilowatts per square meter is measured at 1 meter distance from the glass. At 27 minutes, in the right-hand compartment, combustible items nearest to the glass have auto-ignited. Even without a pilot flame, fire has spread to the opposite side of the partition due to radiant heat transfer through the glass. At 45 minutes, nearly all combustible items, even those placed a greater distance from the glazing, have ignited. Conditions are unbearable for human occupants. By contrast, in the fire resistance rated compartment, none of the identical combustible items have changed. As the test concludes after 60 minutes, the compartment containing the fire resistance rated glass remains fully intact. Ambient temperature remains safe enough for refuge by occupants. Due to the intense heat transfer in the right-hand compartment containing the fire protection rated glass, all combustible materials have either burned or melted. Comparison of key measurements. Maximum air temperature in front of the glazing. 60-minute fire resistance rated glass, 100 degrees Fahrenheit. 60-minute fire protection rated glass, 935 degrees Fahrenheit. This dramatization depicts the extreme difference between the two types of fire-rated glazing components. Both types fully comply with current requirements set by the International Building Code as passive fire-rated building components.
Okay, clear? I think
But
it's
now,
just
how was that easy? I mean, in 20 minutes, it already looked too bad to be there.
right.
The conditions look pretty bad in 20 minutes.
Yeah, well, that's a
But
question.
it's-
Where you install this type of fire protection? You know, for each building, you will have a fire plan, so to speak. The compartments, the fire compartments, the division of the building, and the barriers between the compartments have to be chosen right. So you have to know where you have combustible materials. There you probably should not use this type of protection. You should use EI. Where you don't have it, for example, concrete corridors, concrete corridors, which just are there to lead people out of their offices quickly and without any delay. There you can use E class, no problem.
Yeah.
Yeah.
So it's actually to do with so if you're going to go with the E60, you need to make sure that you specify the correct kind of materials inside that space.
Right. Because what you don't want is the self-ignition. This is a let's say dramatization of what happens. Yeah, you probably would never put a E element in front of a chair or a living room or something, because you would have the self-ignition, which you don't want. You want to just keep the smoke and the fire out. No, the heat is in this case secondary. Yeah. So in those sections of the building, you can use this type of class.
I'm following.
I mean, protecting a building from a fire is really a more complex task than just choosing the elements. You have to know the let's say the number of occupants. You have to know the size of the corridors, size of doors, distance from between the doors which you have to open. Lighting and so on. So there is many factors that will determine which class you should use. You will most likely have a recommendation already from the architect, and you have to fine tune it and then optimize it also cost-wise. So it's a more complex topic than just choosing. But this is what I wanted to explain to you is now just the principles of how these systems work.
Yeah.
Okay. Good. So. This is it. This is the comparison, and now you see also the slide I showed you before. The bending of the door. These elements not only get very hot, they also bend, they expand, and this is why for all doors you have to install a rebate mechanism. This is a bolt on the hinge side, which would prevent the door from opening. Yeah, because we have two hinges usually. And the middle of the door, the central section is not protected, so here the bolt will keep it in place. Latch and bolt locks, not roller latch locks. Rollers will open up. You see the bending will cause the lock to open. So we always use the latch and bolt locks. Doors higher than 2 meters must always be equipped with a top locking point, because this corner is quite big and it's not protected. So even on a single leaf door, you may get some gaps here and smoke entering. Yeah, it's actually the smoke that needs to be kept under control more than the fire. The smoke kills more people than fire itself.
Thanks. People just get knocked out.
Excuse me?
So yeah, to stop people from fainting or passing out.
Yeah, or just suffocating from fire. I mean, the most victims in a fire die from smoke inhalation. I mean, 95%. Hardly anybody burns alive. You know, before that he has suffocated. So that's the situation here. The gaps are important to be kept under control. The gaps between the elements. Then all electric strikes and all electric elements must be tested and approved up to 1000 degrees. And also the junction elements, so how you connect the individual elements. For example, how you connect the door frame, the outer frame to the building. This is also something that must be observed, must be followed according to the testing results. As tested, so approved. This is our rule in fire protection always. Yeah. So these 5 points you will always find on any fire door. Okay, then we have a few slides here about the DIN norms, which I already explained to you. I will skip this. Just briefly go through bullet protection. Bullet protection means you're protecting the inside of the building from damage through projectiles. There is tests. This is actually the only test we don't run here on site in Obrit. There must be a special lab that has the equipment that shoots the right bullets, right projectiles with the speed and weight and so on. So they do it for us. Okay, so these are the elements that are shot at. Oftentimes, it's not only the door itself. It of course has to be the frame and the fixed elements around the door. They all have to fulfill the same class. The classes are actually determined according to the type of weapon and the weight and energy of the projectile that hits the element. So FB1 would be a small shotgun, pretty light projectiles, slow gun, so little black powder. Then we go to the handguns, class 2 to 4, and then it gets really heavy. FB5 to FB7 are machine guns, heavy-duty shotguns, which you see here also on the this is the speed and the weight of the projectiles. So heavy projectiles and a lot of speed, so more energy.
Oh.
So this will determine the class. And according to that, of course, you have to protect the element using more or less steel inserts in the end. This is how you do it. This is an overview of our systems, and they can all be equipped with, as you see here, or produced in these classes. So we can do pretty much everything. Even facade can be equipped all the way to FB4, which is a Magnum 9mm Magnum handgun. So a lot of possibilities here, and unfortunately, we sell more and more of these systems as our world is becoming, well, not precisely.
Not
Exactly. So this is it. So here an element that was tested. The weakest points are usually aimed at, and then you see did the projectile penetrate or not. Good. Emergency systems, we briefly covered that. These are the panic doors, either equipped with a handle or a push bar. Then depending on the type of building you are in. Burglar-resistant systems are protected against crowbars like these, against angle grinders. Then again, you have different classes here, and the classes are okay. Sorry, this is in German, but I will just explain to you the logic between it. The classes increase, so RC1 is basically just no tools. Your shoulders, your body weight. This is the lowest class, and the highest class will allow tools like angle grinders, axes, sledgehammers, drill machines, breakers, and so on. And of course, the time of what do you say, of impact, I mean, of breaking exactly, increases. So it gets, you have to, the element has to resist for a longer time, more impact. So this is how this table is built. And we can build elements up to RC6. Finger protection, this is what I already mentioned, protecting small fingers, children's fingers from getting crashed in the doors mostly. We can do it in different ways. We either have a round profiles that close the gaps, so they minimize the gaps to below 8 millimeters, or, so this can be done with a profile, round profile. Here, instead of hinges, you would use pivot bearings on top and on the bottom. Or we can also, this is actually good for for several systems, Yanisol, the insulated system, as well as the non-insulated systems. And we also have a fabric protection. It is not shown on this slide, but there is a second system also that you can use to protect fingers. Okay, these are the additional profiles. On Economy 60, you use an additional profile which you attach to the existing profile. On Economy 50, it's integrated already. So this is the elements, and again, always the aim is to create gaps smaller than 8 millimeters or greater than 25 millimeters. Yeah, this is it. This is a short walk through the safety systems. I realize it's a lot of information, but look, from your comments, I read that you can follow everything, and we will do more on this. We will go more into detail on these safety systems in the future. This is just a short overview.
Yeah, no, but I'm appreciating I appreciate the nuances of the detail.
Mm-hmm. Sure. So you know where we will dig in deeper later on.
Yes.
All right. Okay, so that's it, guys. Yeah, the first half of the day is over.